Okay, in this video we're going to try and find this integral here. Once again, this is a quadratic. There's a quadratic under the square root sign. We cannot factorize the quadratic equation or expression, but even if we could factorize it, it would be impossible to split it up into partial fractions. So therefore, the idea of partial fraction will not work. We also can't use substitution method, because if you try to differentiate this function into the bracket, the quadratic expression, we're going to end up with 2x plus 1, and that is not featured in the numerator, so we cannot use the substitution method. So we don't have a function and its derivative. For that reason, we are left with trigonometric substitution, and in fact this is going to turn out to be tangent substitution. The first thing we want to do is to rearrange this, to rewrite this as in vertex form. So let me just show that quickly. I will erase it, and then because I think I've jumped this step. So x squared plus x plus 1, we want to write this in vertex form. To do that, I'm looking at the coefficient of x, which we normally refer to as b. So I'll write this as x squared plus x, and I will put plus 1 at the end. But in between, I'll take the coefficient of b, which is 1. So I'm going to add a half the coefficient of b squared. So coefficient of b is 1. So I take that 1, divide by 2, or halve it, and square. So I'm going to add that. But if I do that, then I've now changed the expression. So in order to maintain the expression or the value of the expression, I have to subtract that value again. So I will subtract a half, or a half squared. Okay? By writing this, what I have, the first three terms are now a perfect square and can be expressed as x plus 1 over 2 squared. And this is 1 over 4, so minus 1 over 4 plus 4 over 4. 1 is equivalent to 4 over 4, so this becomes 3 over 4, like that. Okay? So we have expressed this in vertex form. Why do we call this the vertex form? It is because if this is a quadratic function, if this had been a quadratic function, like there was a y there, then what this is telling me is this graph passes through the lowest point on the curve is going to have coordinates negative 1 over 2, comma 3 over 4, like that. So the vertex, so that lowest point there is called the vertex. It's going to have coordinates negative a half and 3 over 4. This is the reason why we refer to this as the vertex form. Okay, but now let's move on, because that's not our interest. We are now going to replace where there is that function there, we will remove it, and it's in its place we are going to put this, because they mean the same. All right, let's do that now. By completing the square, the quadratic radicand, this expression there, is going to reduce to that. So that's the calculation we've just done. So then we're going to replace that on this function here, on the integrand. So the integral now becomes that. Okay, so the numerator is still there. We have a dx here, but in the denominator now we replace with that expression there. It's the same thing. By looking at this, I can tell that what I need is a tan substitution, so that I can have tan squared plus 1. So I'm going to choose my value here appropriately, so that I end up with 3 over 4 tan squared of theta. Okay, to do that, I have to let x plus a half be equal to the square root of 3 over 2, so that when I square the square root of 3 over 2, I'm going to end up with 3 over 4. Okay, so let x plus a half be represented by root 3 over 2 tan theta. If I do that, then of course when eventually I have to put this in, it's going to turn into 3 over 4 tan squared of theta. I hope you understand that. Now we differentiate both sides. This becomes dx. The left-hand side is dx. The right-hand side becomes root 3 over 2 sec squared of theta d theta. The derivative of tan is sec squared theta, which is also the same as 1 plus tan squared of theta, which is what we want to have in there. Okay? So with that in mind, let's move on. By the way, you can rearrange this so that tan of theta, you can show if we remove this and bring to the other side, we can show that tan theta is 2x plus 1 over root 3. We can also take x a half to the other side and show that x is root 3 over 2 tan theta minus a half. All that does not really matter. I'll write them again. So now we want to substitute that result here. We found a value for dx. We can rearrange to find x, and we also have something to do here. So let's see what happens. We will use this substitution. We agree that we let x plus a half be equal to root 3 over 2 tan theta. We also differentiated and got dx as root 3 over 2 sec squared of theta. We're going to need that. That's why I've put them there. But now let's move on a little. So this is our original expression after we had removed this and replaced with the vertex form. That's what we get. So now I'm going to replace x with the equivalent. So from here you can see x equals root 3 over 2 tan theta minus half. Okay, so that should take the place of that one there. Okay, the x plus a half squared, because if I square this, then I have to square the other side. So that's going to be 3 over 4 tan squared theta. I'm going to replace that with 3 over 4 tan squared theta. And by doing that, I can now take 3 over 4 out. Okay, so if it is inside the bracket, it is 3 over 4, but if I take it completely out, it becomes root 3 over 2. I can leave root 3 down here and put 2 up, but let's see what happens. Oh, by the way, delta x, this delta x here also has to be removed now because everything has to be in terms of theta. So if I remove delta x, I put the derivative that I found there. So then delta x becomes root 3 over 2 sec squared d theta. Okay, so what do I get now? I open this bracket here, so root 3 over 2 sec squared of theta multiplied by that first term in there gives me this 3 over 4 tan theta sec squared theta minus, then this multiplies the half and I end up with root 3 over 4 sec squared of theta d theta. The denominator still remains the same. Okay, now I can simplify the numerator and the denominator. The denominator becomes, this is root 3 over 2 outside, and then I'm left with tan squared theta plus 1. Tan squared theta plus 1 is sec squared of theta. I can write that down briefly. So I'm saying tan squared of theta plus 1 is the same as sec squared of theta. So if I find the root of this, then I must find the root of that. So the root of tan squared theta plus 1 must be sec theta. Okay, so the denominator, all this denominator really becomes just sec theta, except that I'm going to have root 3 out here. Root 3 will remain out down there, and 2 is going to go up. Okay, let's see how that what follows. Okay, so if I simplify, we will see we have agreed that the denominator remains as just sec theta. Root 3 from here remains down, and the 2 goes up. That's this one here. So this is the 2 and that's the root 3. But we also have 3 over 4 from up here for this term here. We have 3 over 4. So we have that 3 over 4, and then we have 2 over root 3 coming from down here, and sec divides this and cancels one of the sec, so I'm left with just 1 tan and 1 sec, which we have here. If we do the same here, sec cancels one of the sec, and we are only left with 1 sec there. Root 2 over root 3 that we have here also goes to this one here, and then we have root 3 over 4. I hope you can see this without me having to write it down. And now all we have to do is simplify. If we simplify this, we get 3 over 2 root 3, okay, which is also the same as, I think, root 3 over, let's write that afresh. It becomes root 3 over 2. Let's just try to simplify that. We get root 3 over 2. So root 3 over 2, so we get root 3 over 2 here. Root 3 over 2 simplifies there. Let me go back slightly. So from here, if we simplify this, we get this 2 goes here once, right? So 2 cancels here once, and it goes here twice. So now I'm left with, for that I have, I can write 3 over 2 root 3. I can rationalize the denominator by multiplying by root 3 and root 3 like that. So this becomes 3, which cancels that, and I'm left with root 3 over 2 like that. Similarly, if I simplify this, root 3 and root 3 will cancel, and I'm left with 1/2. Okay? And so when we simplify that, this is what we get, minus 1/2 sec of theta. When we reach here, basically the work is done because we know this integral. Tan theta sec theta is actually the result of the derivative of sec theta. So if you differentiate sec theta, you get tan theta sec theta, and therefore if we integrate this, we should get sec theta, okay? And so our answer for this part is going to be root 3 over 2 sec theta. And the derivative of sec, in the series of integrals that I've done so far, I've done an integral of sec, and I've also done an integral for cosecant. So if you go in there, you should be able to see this integral very rapidly. If you're a university student, this now should be in your head. The same way you would remember the derivative for simpler expression like sine and cosine, you need to know the derivatives for sec and for cosecant. And therefore, the integral of this therefore becomes root 3 over 2 sec theta. So this is the integral of this. And the integral of sec theta is a half ln, is going to be ln sec theta plus tan theta. So I have shown this result elsewhere in these pages. It's one of the videos in this series. Okay, so just take a look and see how we arrived at that because we proved it. So effectively we've done the integration. The problem is that our answer is in terms of theta instead of x. So we want our answer to be in terms of x. In order to do that, we have to go back and look at our substitution. We made a substitution. That 1 from what we got here, 1 plus x plus a half, we said we made it root 3 over 2 tan theta. So if we rearrange that, this is what we got, okay? So with this in mind, so this comes from the substitution. So you must remember that we will always use the substitution to come up with a right angle triangle from which we will find sec theta, okay? So with that in mind, tan theta is 2x plus 1 over root 3, meaning that we know that tangent of theta is opposite over adjacent. So this is our opposite and that's our adjacent, and this is the angle theta. So if that's the angle theta there, this is the angle theta, then this is the opposite side to theta, so the length of this must be 2x plus 1, okay, like that. And the adjacent has to be root 3, so that we have tan theta is opposite over adjacent, like that. And so what happens is we have to find the value of the hypotenuse, okay. So the hypotenuse is going to be, so let's call this t, for example. Then we are saying that t squared must be equal to root 3 squared, which is 3, plus this squared, which is 4x squared, plus 4x plus 1. All right, so this is the same as 4x squared plus 4x plus 4, 3 plus 1 there, okay? So this is t squared, so t has to be the root, and I can write this as 4 into, this is 4 into x squared plus x plus 1. So if I find the square root of this to find t, then I end up with 2 square root of x squared plus x plus 1, like that. And this is the value of t, so this must be the value of the hypotenuse there. We're going to replace that t here with this result here. Let's do that. And so we will always use our substitution in the process of converting our integral back to values of x. We will need that substitution that we had used earlier, make tan subject and have this arrangement so that you can replace it in the right angle triangle like that. And so we are saying the hypotenuse must be given by that. Okay, now sec is 1 over cos. Cosine is adjacent over hypotenuse, so the reciprocal of that, which is sec, must be a hypotenuse over adjacent. So we can say that we can replace sec there with 2 square root of that over 3, like this. So this must be the value of sec, and already we know the value of tan. So all we are left to do now is to take these values for sec and for tan and replace them there, and we are done with this integral. Okay, so the integral of x over square root of x squared plus x plus 1 dx is just that, which is, well, so by the way, so if we put this in here, the root 3 over 2 is going to cancel with 2 over root 3, and we will just be left with the square root in there. Okay, so that is what this becomes, and the other one becomes half ln of sec, which is this thing here, this time nothing to cancel it with, so it remains as it was, plus tan, which is that thing there. You can simplify if you want, or you can leave it the way it is, and that is the integral, is the value or the result of that integral there. Okay, hope you understood. Again, if you have any question, let me know. Place your comments in the comment section, and I will be able to respond accordingly. Hoping you like the video, in which case, if you are new to the channel, please like it, and then if possible, please consider subscribing so that you're able to get notification whenever a new video shows up in the channel. All right, thank you very much. I'll see you in the next video.